Okay, and we know that the hyperbolic sine of x is equal to e to the x minus e to the negative x divided by 2. All right, so the first thing we want to remember is our e to the x. So that's the sum from n equals 0 to infinity of x to the n over n factorial, which is 1 plus x squared over 2 factorial plus x to the third over 3 factorial, and it keeps on going. Okay. So we have our e to the 2x. We just replace every x with 2x. So that's just 1 plus 2x plus 4x squared over 2 factorial plus 8x to the third over 3 factorial plus 16x to the fourth over 4 factorial, and it keeps on going. Okay. And our e to the negative 2x, we just replace every x with negative 2x. That's going to be 1 minus 2x plus 4x squared over 2 factorial, since it comes out to be even, minus 8x to the third over 3 factorial plus 16x to the fourth over 4 factorial, and then it goes on and on and on. Okay, so what we're going to do now is we're going to subtract these two. Okay, so that means that e to the 2x minus e to the negative 2x is going to give us 1 minus 1, which is 0. 2x minus negative 2x is plus 2x. Yep, so you're going to have 2 times 2x. Okay, and the only reason we're doing that is because once we divide by 2, we're going to have to cancel that out. Okay, so here you have 4x squared over 2 factorial minus 4x2, so that cancels out. And really, all of our even ones will cancel out. Okay, so here you have 2 times 8x to the third so that would be 2 times 16. Oh, 4x to the third, sorry about that. Okay, so 2 times 8x to the third over 3 factorial. Plus, then we have to the 5th power, that would be 2 times to the 5th would be 32. 5 factorial, and it keeps on going and going and going. Divided by 2. Where those 2's will cancel out.
So you don't have to manipulate the 8x cubed and the 32x?
No, actually that would be 2 times 16. Yep, because you have 16 and 16, so that would be 2 times 16. There we go. I mean, not 16, 2 times 8.
The 16 and 16 cancel out.
I mean, not the 16, I meant the next one, which would have been the 32. So that should have been 2 times... No, that was right, 2 times 32. That's what I get for doubting myself.
That was 4x, or 8.
Which one?
8.
Oh, 8. Oh. I'm trying to listen to him and rewrite what I erased at the same time. All right, what were you saying?
Because you manipulated the 2x plus the 2x to make it the 2 times 2x.
4x.
Mm-hmm.
Right? So then don't you have to do that for the 8?
Right, so it's
Okay, two.
8x cubed plus the 8x cubed is the same thing as 2 times 8x cubed.
Yep, 2 times 8x cubed.
He's just
And then you have
he's just keeping that
2
2 on the
times
side.
the x to the 5th would have been x to the, well, 2 to the 5th minus 2 to the 5th, which would have been 32 x to the 5th. So once we add those two together, it would have just been 2
Oh,
times
okay.
x over that. So it was just kind of manipulated a different way.
Okay.
All right. So that leaves us with 2x plus 8x to the 3rd over 3 factorial plus 32x to the 5th over 5 factorial plus, I believe that would have been 32, then 64,
128.
128. So 128 x to the 6th over 6 factorial.
X to the 7th.
7, thank you. That's what I meant. Seeing if you're paying attention. All right, now once it's all simplified and everything cancels out, then you have your 2x plus 4x to the 3rd over 3 plus 4x to the 5th over 15 plus 8x to the 7th over 315. Which would be your first 4 terms. All right. So any questions on that one? All right. And move that over a little bit. All right. Okay, we have about 2 more examples. I just went ahead and put them in the scan notes. Pretty much the same steps. Okay, I wanted to get started on the parametric equations. So the main idea behind parametric equations is that so far, if we have a function that fails the vertical line test, we just kind of throw it away. Okay, it's not a function. We move on to the next one. So the same way you have the negative square roots kind of gave way to the complex numbers, all of the ones that are no longer just regular functions kind of created parametric equations. So when we graph them, you'll see that they'll kind of go all over the place. So this is more or less just the manipulating of it first, and then on the next class, we'll learn how to graph it. Okay. So let's say if you let some function f and g be continuous functions. And usually they use t because it represents time. Even though they say t isn't time, it's always used for time, so we just call it t. On an interval that we'll call I. Then the equations x equals some function of t and y equals some function of t are called parametric equations. Okay. Now this one, once you have your parametric equation, the new variable t is called your parameter. so we leave that up there for a few more seconds. All right, so for our first example, let's say if you have the curve 3y squared equals x plus 4y minus 8 is correctly parameterized. I think that said it correctly. By what pair of equations?
You can pronounce a made-up word any way you want.
I know, that's why I watch the spelling bee in awe. Okay, so in other words, this is just saying write x and y as two functions of t. Okay. Now with this one, it's not too bad, because if you look, you have a lone x sitting there. So really, you could just solve for x. Okay, so you can just make x equals 3y squared minus 4y. Let me straighten that up a little bit. Plus 8. I know, that's why I haven't looked up at it. Though. That looked a little bit odd.
Probably doesn't have. That's like, why would you have x plus 4x? Why not just 5x?
Yeah, and looking at it, I was like, yeah, that looks a little bit iffy. Okay, so if we let y equals t, then now our x is a function of t, which is 3t squared minus 4t plus 8. And if y is equal to t, then that just means that y of t is equal to t. So we have our parametric equations. They don't have to be complicated, just have to be functions of t. Yes.
Will the other variable always equal to?
For this section, most of them will just equal t, but as you get further in, they'll get a little more complicated. This is more of an introduction to it.
So the easiest you can get.
Oh yeah, this is the easiest, by far,
It only goes downhill from here.
pretty much. All right, so let's say if we have the curve 3x to the fourth equals y minus 5x squared minus 3 is correctly parameterized by what pair of equations? Oops, there we go. Okay. Now with this one, we see we have our lone y. Okay. So we can just make y equals 3x to the fourth plus 5x squared plus 3. So in this case, we'll let x equals t. So let x equal t. So that means y is now a function of t. Y of t is equal to 3t to the fourth plus 5t squared plus 3. And since x is equal to t, it's a function of t. X of t is equal to t. So those are your two pair of equations. Yes.
Never mind, I think that's where you're gonna go. I was gonna ask like a question I think you're just gonna do next. The next example.
Oh, you mean going back the other way?
No, like,
Oh.
so what if it wasn't a lone wire? What if it was like 3 wires, something like that? Is it just that you have to divide?
If it was which one?
Like if the lone variable was just like the head coefficient, do you just divide it out? And it would still be the same? Or like, do you do something different?
Like if it was the same equation, but instead it was 3x to the fourth equals 2y minus 5x squared minus 3.
Oh yeah, then you do the same thing. Yeah, then you just divide.
everything.
Oh, okay.
Okay.
Yep, that's what you were saying?
Yeah.
Oh, okay. Yep, that's all you do.
What if the lone variable has an exponent? Would you just
Square root.
Yeah,
root
just
it?
square root it.
Rooted by the power.
Yeah.
Manipulate the equation to get a variable by itself.
Pretty much. That's it. So the whole goal is just to get the variable by
Except
itself.
the other one equals t.
Yeah, exactly. All right. So let's say, oh, anyone's still writing? Oh, okay. Okay, so suppose an object moves from the xy coordinate point (4, -9) to the point (-6, -5). Okay, so these coordinates are in yards. And takes 10 minutes to travel from one point to the other.
This physics?
Okay, I'm supposed to sell it.
Okay. So we don't have to solve it, we just have to get the parametric equation. With respect to time, for the position of the object. Okay, so the first thing we want to do is find our change in x, which we know is our x2 minus x1. Okay, so our -6 minus 4 is -10. Okay, so that means, kind of block that off a little bit. We went -10 yards in 10 minutes. Okay? Or -1 yard per minute. Okay, so that means our function is going to be, or our parametric equation rather, is going to be -1 times our time plus 4. Because remember, we're started at 4. So when t equals 0, we're at 4. So for every minute that goes by, it goes down 1 yard. Okay. Okay. So we'll do the same thing for y. Next, we find our change in y. Okay. So that's -5 minus -9. Or better yet, y2 minus y1. So -5 minus -9 is just +4. Okay, so that means, I'll put that over on the side, moved 4 yards in 10 minutes. Or 2/5 yards per minute. Okay, so that means your parametric equation for y is equal to 2/5 times time minus 9. Because remember, you're starting at -9. So that's your starting y point. Okay, so those are your two parametric equations.
Now, would you ever combine those?
Oh yeah. And actually we're going to do an example of combining them. All right, so any questions on that one? All right. Do one more example of that one, and then we'll combine them, which is what they call eliminating the parameter. All right. Oh, anyone's still writing? Okay. Okay, so if we have an object moves from 0.76 to the point 3 -5 in 15 seconds. Okay, so the coordinates are given in millimeters. Respect to time on a standard plane. Find the parametric equation for the motion of the object. Uh-oh. So the first thing we do is get our change in x. Which is our x2 minus x1. Okay. So we go from 3 minus 7 is -4. Okay, so you go -4 millimeters in 15 seconds. Can't simplify it, so we leave it at that one. That means your parametric equation for x is equal to -4 15t, and we started at 7, so it'll be plus 7. That's your starting x value. And once again, we do the same thing for y. Our change in y, which is our y2 minus y1, so that would be -5 minus 6, which is -11. Which means you go -11 millimeters in 15 seconds. Okay, so our y parametric equation is equal to -11 over 15t, and we started at 6, so it will be plus 6. Remember, that's our starting y value. All right, so any questions on that one? All right. Oh, make sure I have enough time to go through these. Yeah. Oh, yes.
So would these be two different functions that we would graph?
Yep, well, they wouldn't be two different functions. How you would graph them is once you have them, you'll say, okay, at time equals 0, what's your x and y coordinates? Then when time is equal to 1, your x and y coordinates. So you just substitute
Okay.
time for 0, 1, 2 for each of them, and those will give you your x and y coordinates. Okay? So that's why it can go in all kinds of different shapes. All right. Any other questions on this one? All right.
You might want to restart your recording.
Ah, thank you.